Good morning, everyone. Thank you very much to Mark and Matt and the whole organizing committee for making this happen, along with the sponsors. I'm happy to be here. So, and Nels Johnson will not be joining us today. He couldn't make it. So you just get me. So, thanks, Phil, for introducing me. And as Phil said, I'm the Energy Program and GIS Manager for the Nature Conservancy, and I'm here to talk to you briefly about a tool that we are creating in collaboration with university researchers and consulting firm analysts and industry advisors. But before I talk about the tool itself, I want to give you some background about where we're coming from and why we're doing this, and how it could be useful potentially to your companies. So first of all, for those of you who aren't familiar with our organization, we're an environmental nonprofit, the leading conservation organization in the world. We're known for using science-based strategies, using an innovative and non-confrontational approach to solving conservation challenges at a large scale. We work with companies, including the energy industry, to help make better business decisions for nature, which in turn can help protect business assets and mitigate risks. We work all over the world, in every U.S. state, and have over 1 million members. In Pennsylvania, we focus on forests and freshwater resources and protecting them for people and all the critters that live in those habitats. So I can't be from a conservation organization and not show you pretty pictures of things. But only briefly, unfortunately. Oh, there's a map missing there. But so I just also want to stress that since this is an energy and GIS conference, we use GIS extensively within the Nature Conservancy for various applications in all aspects of our work, including conservation planning, land protection work, land management, spatial analysis, etc. And on the energy side of things, the Nature Conservancy has taken an approach that we've called development by design, which is about avoiding and minimizing habitat impacts from energy development, or all forms of development, really, including infrastructure and other things. And we have pilot projects all over the world, in California, in the Rocky Mountain West, in Mongolia, Colombia, and in the Appalachian region here. It's the work I'm working on. And the whole idea is the mitigation hierarchy that many of you are familiar with. So first, avoid impacts to important ecological features when possible. And when that's not possible, minimize those impacts using appropriate siting guidelines, for example, or BMPs, and then mitigate those impacts as appropriate, which is most common now for wetlands within the existing legal framework. So just so you have a sense of where this tool fits into our larger strategy, we use GIS extensively in the past few years to do impact assessments from energy development, natural gas, wind, and coal. We did that for Pennsylvania. We projected wind turbines and Marcellus wells into the future, looked at where they were more or less likely to go. We worked with industry on that to review our models, and then intersected those models with conservation priorities for us to get a sense of what kind of impacts we were facing in the future. We are doing that. We're in the final phases now of doing that for the entire Appalachian region. That was funded by the U.S. Fish and Wildlife Service. And those data sets will be available online in a couple of months. So the next phase of our work is really to, okay, we know impacts are coming. Inevitably, environmental impacts occur with any form of energy development. So what can we do to try to avoid and minimize those impacts? And that's where this tool comes in. We've also done work on the freshwater side of things, but I don't have time to talk about any of that. So the rest of my presentation is really focused on this GIS-based tool. So as I said, we're working in partnership with the University of Tennessee, university researchers, and also the Cadmus Group, an environmental consulting firm, and as well as industry advisors. We have confidentiality agreements with 4 companies that have helped us along the way to learn how the industry plans out its infrastructure, and then how this tool could maybe fit into that and complement it. So I want to stress that this is just it's a siting tool for infrastructure at the surface. It doesn't do anything subsurface. So in that way, I see it as potentially complementary to all the excellent technology that you guys are already using for subsurface planning. So our whole objective was to provide an easy-to-use mapping tool for siting surface infrastructure in a way that avoids and minimizes habitat impacts. So again, it's all about avoid and minimize in that mitigation hierarchy that I showed you earlier. And so the tool identifies optimized layouts for well pads, roads, and pipelines. Those are the 3 infrastructure types that it focuses on. It does incorporate existing environmental regulations. So for example, it'll already include, setback distances, required setback distances from property lines, from existing buildings, from streams, from all of that, and it can change by state. But it also includes additional environmental considerations, and that's our focus here, is to try to make it as easy as possible to include those additional environmental considerations, such as habitat fragmentation and habitat loss, that's currently not within the regulatory framework. And it does all this, it looks at environmental impacts and the trade-off between those impacts and the increased financial costs of development. It's a free and publicly available tool, and it will be open source, or it is open source, for modifications as needed in the future. So to walk you through how the tool works, I'm going to zoom into Bradford County up in northeastern PA and give you a fake leasehold. This is a fake leasehold boundary. So as you well know, siting infrastructure at the surface is difficult. We've already seen lots of images of that, and there are lots of factors to consider already. So obviously you have to stay within the leasehold boundary or cobble together as many as you can. You have to account for existing forests because they have to be cleared to site the infrastructure. You need to pay attention to streams and wetlands and existing buildings. You have to connect to existing road networks and pipeline networks. It's already really complicated. But we want to make it easier to consider more factors, such as forest fragmentation. So what makes a good layout in this context? Well, it achieves the things listed here on the left. It maintains intact habitats. It avoids rare species. It avoids streams, it prevents erosion and sedimentation, and it avoids cultural features like schools and cemeteries that you want to stay away from. So all of those things can be measured in GIS with the metrics listed on the right. And they can all be added up in a GIS to come up with an overall environmental impact score for a particular layout based on all of these factors. So as I mentioned, this is a GIS-based tool with a user interface that we are working with Cadmus Group to enhance and make as user-friendly as possible, so you don't have to be a GIS expert to use it. And I'm going to walk you through the steps of the tool. So first, it places gas drainage units, and we're not in the business of doing this, clearly, but this is an essential first step because it determines where the placement zones are for the pads themselves. So we want to have no gas left behind, as you well know, so you want to drain the full leasehold. So you need to place pads in a way that achieves that goal. So this, we hope, will be variable in terms of the number of wells per pad, so you can change the size of these drainage units, the length of the laterals, etc. All of that is user-defined. So once those placement zones, those solid pink rectangles there are the pad placement zones. Then you can identify further pad siting restrictions. So obviously you're not going to put the pad in the middle of the lake. You got to take that out of your world of possibilities, right? So you clip those out, and then those pink rectangles are a bit smaller. So let's just take one possible configuration of well pads, for example. And I know this is a schematic just for illustrative purposes, so don't take this in too much detail. So that's one possible configuration of well pads. Then we need to identify roads and pipelines to connect those well pads to the larger networks, right? So identify road siting restrictions, slope restrictions, et cetera, sensitive habitats to avoid, wetlands, et cetera, and then place access roads to connect those paths. And then the same thing for pipelines. Enforce those pipeline siting restrictions and then place the gathering lines. So once these infrastructure layouts are determined, and the tool goes through hundreds of them at once, for each layout it calculates an environmental impact score based on a bunch of metrics, including the ones that I listed earlier. So it includes forest fragmentation metrics, forest habitat loss metrics, Also related to this slide, sediment yield and sediment delivery estimates for conversion of that particular location to development. And we also have a stream connectivity metric that looks at how culverts or bridges might affect the connectivity of the freshwater network. So once all those things are added up, and costs are also included in this, so the cost of building all of that infrastructure, we can look at the trade-offs between the impacts and the costs. So let's assume that these two layouts cost approximately the same amount to build. But they differ in terms of their environmental metrics. So this is just a small set of examples. And you can see here that given the same amount of money spent on building infrastructure, that layout B has lower environmental impact. And as you can see, that also depends on how you weight the metrics relative to each other. That's an important piece of this, and the user can change those weights. So here, forest habitat loss is weighted much more highly than stream crossings. And you could argue maybe you'd want the stream crossings actually to be weighted more heavily because of permitting costs to the operator and all of that. But so again, that's flexible, and that will be user defined in the tool, although there will be a default set of weightings. So you can come up with a whole bunch of layouts, like I said, hundreds of these layouts, and the tool will then select out the optimized ones, the ones that best balance cost and impact. And so you can you can table these, look at them grouped by approximate cost. And so within each cost category, you'd want to pick the layout that has the least environmental impact. So the assumption here is that the more you're willing to spend, the lower the amount of impact. The idea is if we're trying to decrease forest fragmentation, for example, you don't want to put the road straight through an existing intact forest area. You might want to build it around. Well, that's going to increase your mileage of road and increase your costs. I'd argue in the long run, avoiding habitat impacts and not being close to sensitive areas would end up being a win in terms of business practices. It lowers risks overall. So this is really a shorter term view in terms of higher costs for lower environmental impact. So if you graph these layouts on an XY axis, with the x-axis being the project cost and the y-axis being the environmental impact, you can see how they relate. So A and B were at essentially no additional project cost. It was just what the operator was going to spend anyway. And so again, just by taking into account environmental considerations, you can probably lower your environmental impact at no additional cost. And then if you're willing to spend more, then you can lower it even more. So the tool gives the scatter plot of potential layouts. Each dot is a layout, an infrastructure layout. And so it produces this trade-off curve. So at any given project cost that you're willing to spend, you can find the layout that has the least environmental impact. So why use the tool? Well, to go above regulatory compliance to reduce impacts and minimize risks, both environmental and business risk, really. The tool is really useful for identifying optimized layouts at a pretty large scale for dozens of well pads at a time. Certainly you can use it for a small leasehold to only site one well pad, but that's relatively easy for a human to do given certain access constraints and other things. But citing dozens of well pads at a time on a large leasehold, for example, that's really where the tool has its maximum utility, because it's really hard for a human to do that, to think about possible pad locations over a large area and then all the possible routes for the pipelines and roads to connect those pads. So even if you don't want to use the tool to find those layouts for you, you could, and you already have a couple of different layouts in mind, you can put them in the tool and have the tool tell you what those environmental impacts are estimated to be and what the financial cost is estimated to be. That's another potential use. Or if you know where your pads have to go, you could still use the tool to site your linear infrastructure, to site your pipelines and roads. So the timeline, we've been working on this for over 2 years. It's been a long process, and as you can imagine, it's really tough to model the real world in terms of accounting for all the factors that go into infrastructure placement, and we fully recognize that there are plenty of things that we can include in the model, such as landowner preferences about where things go. We know that's important. There's just no way to include it, so this is why we're calling it a decision support tool. It's not going to give you the answer, but it's going to help you find better options that balance a lot of things. And it can really be a complement to existing planning processes. So the beta version of the tool is ready now. It's not publicly available because we are applying it to real places in partnership with our industry advisors to see how well it does, compare what it spits out to what industry has already laid out for certain leaseholds, and we're going to refine it from there, learn as we go. And then incorporate additional metrics that we may have missed or something. And then we're enhancing the user interface, which I mentioned earlier, along with the contractor. And we hope for a public release in the spring. I'm leaving that as a vague date because we'll see how much refinement needs to happen. But we are confident that the tool can at least help companies think about how to reduce environmental impacts and potentially costs in the long term with this tool as a complement to their existing planning processes.